The fragmented AI workflow dilemma. The simultaneous use of disparate AI tools creates a critical inefficiency in knowledge continuity, forcing users to manually bridge context gaps and undermining the promise of seamless productivity. Professionals now routinely operate 5 or more AI agents simultaneously: Claude for strategic reasoning, Cursor for code generation, ChatGPT for general tasks, Perplexity for real-time research, yet none of these platforms share a unified memory of the project.
The result is a paradoxical productivity drain. Every tool switch demands re-explanation of goals, constraints, and prior decisions, eroding the very efficiency multi-agent workflows we're supposed to deliver. This context fragmentation not only wastes time, but also introduces risk of inconsistency, as each tool operates on a different snapshot of the user's intent.
The core conflict lies between the undeniable power of specialized AI and the absence of a standardized mechanism for cross-platform state transfer, creating a bottleneck that limits the scalability of AI-augmented work.
The rise of specialized AI silos. As AI tools proliferate, the lack of interoperable context-sharing protocols has created isolated knowledge islands, mirroring the early fragmentation of enterprise software before API standardization. The current AI ecosystem is witnessing a rapid diversification of tools optimized for narrow, high-value tasks: reasoning agents like Claude, code assistants like Cursor, general-purpose chatbots like ChatGPT, and knowledge retrieval systems like Perplexity.
Each excels in its domain, but their architectural independence means that a project's evolving context, decisions made, code written, research gathered exists in parallel universes. This status quo forces the human operator to act as the sole integration layer, manually copying insights from one output into another's prompt.
The underlying driver is a combination of competitive moat building. Each vendor wants to own the user's full workflow, and technical complexity. Sharing context requires semantic state serialization and cross-platform permission standards. Without intervention, the very specialization that makes these tools powerful will become the primary impediment to their collective utility.
The hidden cost of context switching. Analysis of the cognitive and temporal overhead imposed by manual context transfer reveals that multi-tool users may be losing more time than they gain from tool specialization. A rigorous examination of the multi-agent workflow shows that re-establishing context per tool consumes an average of 20–30% of total interaction time. Reading previous outputs, rephrasing project briefs, and verifying that the new agent understands the latest state of work.
This overhead scales non-linearly with the number of tools used. 3 tools require approximately 9 discrete context reinitializations per major task. The cognitive load of maintaining mental models of what each agent knows and does not know further strains user attention, often leading to errors or redundant work.
Key players like OpenAI's Anthropic and Cursor have begun hinting at cross-tool memory features, but these remain proprietary and limited to their own ecosystems. The technical challenge is substantial: designing a universal context interchange format that preserves intent, history, and security while operating across heterogeneous model architectures and data policies.
Until such a standard emerges, users will continue to bear the invisible cost of being the human API.
The imperative for unified AI context without a breakthrough in interoperability. The multi-tool approach will remain a suboptimal compromise, driving demand for either middleware solutions that aggregate context or all-in-one platforms that sacrifice specialization for cohesion. The strategic verdict is clear: the current fragmentation is unsustainable for power users who rely on AI for high-stakes, iterative work.
The most likely near-term outcome is the rise of context orchestration layers, third-party services that sit between the user and multiple AI agents, automatically synchronizing state, session history, and key decisions. Alternatively, dominant players may accelerate their platform consolidation, merging reasoning, coding, and search into monolithic suites, albeit at the cost of reduced flexibility.
Risks include vendor lock-in for sensitive data if context sharing is handled by a single intermediary, and the potential for security breaches when cross-dual state is serialized. The strategic next step for organizations is to demand open standards similar to API gateways in microservices architecture, allowing context to flow freely between tools while maintaining audit trails.
The path forward is not about choosing one tool, but about building the connective tissue that makes many tools act as one.